My name is Morgan, and today I'm going to be telling you how to graph a cubic function. So with any function, you'll usually start off with an equation. And so any cubic function equation will have a chunk of the equation or the whole equation to the third power, or it might even just be a number to the third power, or some people refer to it as cubed. Cubed and to the third power are the same thing. And so our equation is f of x equals negative 2x plus 4 in parentheses to the third power. So with this equation, we're going to use a table and take points and substitute them in for x, and those will give us f of x values, and that will give us points for our coordinate plane. So my table is already pre-filled out just so it's easier and the process doesn't take as long, but I'll walk you through it. So personally, I like to find the vertex first so that I know where my curves are going to go, and since it's negative, I know that it'll curve up to the left and down to the right, so I just substitute in 2 because I know that 2 times negative 2 is negative 4, and negative 4 plus 4 is 0, and then I do the outside of the parentheses next, which is cubed, and that still gives us 0. So our first point is 2, 0. So I thought, well, let's do something close to 2, so I choose 1, and I do negative 2 times 1 plus 4 to the third power is 8. So then I plot my point, and then I know that this isn't my curve because it's too far away from my vertex, so I choose the amount in between, which is 1.5. And so when I put 1.5 in, I get 1.5 times negative 2 plus 4 to the third is 1. And so then I plot that point. Then I know that I need something larger than 2 by 1/2, so I do 2.5. Negative 2 times 2.5 plus 4 to the third power is negative 1, and then we graph that. And then I put in 0, and you'll find out why later, but negative 2 times 0 plus 4 to the third power is 64. And so now all functions are graphed with either a line or a curve, and so our curve looks like this. It's not the prettiest, but it's still a curve. And so it curves up to the left, like I said, and down to the right. And there's arrows at each end, and I'll explain the arrows in a little bit. But that means they go on forever, basically. So now we're going to learn about some features of the cubic function, or this cubic function actually in particular. And so the features that we're going to learn about right now are domain, range, vertex, symmetries, and asymptotes. So with any domain of a function, it is where the function can go on the x-axis, or the x values that can be put in and still work. So on ours, we have arrows. Our vertex does not restrict the function. So it can go anywhere. It is free. That's what we'll call it. And so for our domain and range, we always put them in brackets. But so we know that it can be anything. So that means it can be all real numbers. So for our domain, we do bracket x, and then we use a vertical line. That means as long as. So x is available as long as. So x as long as x equals r. And r stands for all real numbers, and then you put a bracket at the end again. And same with range. And this is where our arrows are really helpful because that lets us know that it'll go on forever and on forever this way. And again, the arrows are important somewhere else too, but we'll explain that later. And actually we got lucky because our domain and range are actually the same in cubic functions, and so it's f of x. So bracket f of x as long as f of x equals all real numbers, and then another bracket. And with all cubic functions, it'll always be all real numbers for domain and range. Always, always, always. Just remember that. And it makes the process so much easier. And so, like I said in the previous slide, I always like to choose my vertex first for cubic functions because then that lets me know where I'm going and where my graph will start. And so we already know our vertex because that is in the middle of our curve of going up and down. But when we remember to plot our vertex, we're trying to get a chunk where the chunk of the equation where x is to equal 0. So we know that 2 times negative 2 is negative 4, and negative 4 plus 4 is 0. So we know that, and then 0 to the third power is still 0, so then we get 2, 0, and then as you can see here, it's right in the middle of where our curve goes up and where it goes down. So that kind of helps us in that matter anyway. So then our symmetries. In cubic functions, there isn't a line of symmetry or lines of symmetry. We just know that it can be rotated and it'll be symmetric to our original graph. So that means our only line of symmetry is rotational symmetry. So that's it. You just have to remember that and you're good to go. Now, an asymptote, some of you might not know what that is. An asymptote is a line where it could be negative 2 or it could be a y or an y-axis line. It could be anything, any line on the x or y axis where the function's graph will approach it, but it'll never hit it. It'll get down into really, really tiny fractions like 1/16th and 1/20th, and it will never reach that line. So in a cubic function, considering our domain and range is all real numbers, then we don't have any asymptotes, so we just write none. The next features that we're going to talk about is X-Intercept, Y-Intercept, and end behaviors. So if we start with the X-Intercept. X-Intercept is where any point in our function hits this line of the x-axis, obviously. And so lucky for us, when we were finding our vertex, we actually found our x-intercept because we need it to equal 0. But if you don't get that lucky, you substitute 0 in for f of x. And when you substitute it in, you solve it from there to find x, and then you'll do x comma 0. So we already know ours because we put in 2, which is 2 times negative 2, is negative 4 plus 4, again, is 0. To the third power is, again, 0. It's like the 4th time I've said it, but it really comes into play here. And so we have 2 comma 0. So that is our x-intercept because it hits right here on the x-axis. So then our y-intercept is any point in our function that hits the y-axis. And this one, if you refer back to our table that we were looking at, this is where we substitute 0 in for x, because 0 is always first, because it'll be 0 and then it'll go up or down on the y-axis. So we substitute 0 in for x because that's where it is on the x-axis. And so when we do that, we end up with 0 comma 64, which again isn't shown here because our graph only goes to 10. So if you just picture it going way, 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 way up, and that's when it will do that. So then end behaviors. End behaviors is when the arrows here come into play. And if you don't know, for our end behaviors, we kind of have to know where the infinities of the axes are. So if we're going positive, we're going to the right on the x-axis, it is positive infinity. And if we're going to the left on the x-axis, it is negative infinity. If we're going up on the y-axis, it's positive infinity. And down on the y-axis, it's negative infinity. So let's look at the arrow that is going to positive infinity. So x is approaching positive infinity, while y is approaching negative infinity. Because as you can see here, it's going down and to the right. And so that's how we memorize it. So then if we look at our next arrow, it's going up to the left. So to the left is as x approaches negative infinity, y approaches positive infinity. So we get x approaches negative infinity, f of x approaches positive infinity. So that's how the end behaviors work. Now let's put it all together and review cubic functions. So again, we have our equation here, which again, always look for the cube or the squared, not the squared, the cubed or the to the third power. And then we fill out our table with different points, so we substitute in for x. And then we graph with a curve where it curves up when it's a negative number at the vertex, or down if it's a positive number at the vertex. It'll curve up to the left if it's a negative, and up to the right if it's a positive. It'll curve down to the right if it's a negative, and down to the left if it's a positive. That's kind of hard to remember, but you'll figure it out. And just remember it curves at the vertex. So then we remember that our domain and range are both all real numbers, and remember the vertical line means as long as. So our domain is x as long as x equals all real numbers, and f of x as long as f of x equals all real numbers, and remember those are put in brackets. Our symmetry is rotational because there are no lines of symmetry, which is pretty easy to remember with this because it's just you have to memorize it. Then our vertex is 2, 0, which again is where our curve will go up or down depending on positive or negative the way x is being multiplied by. And then our x-intercept is where it hits the x-axis, which is 2, 0 for our x-intercept and 0, 64 up here somewhere. And then there are no asymptotes because it isn't approaching a line. It goes on forever and will hit every point. Our end behaviors, again, x approaches positive infinity, f of x approaches negative because it's going down and to the right, and then x approaches negative infinity because it's going to the left, and f of x approaches positive infinity because it's going up. Okay, thanks for learning about cubic functions with me today, guys. I hope you learned something, and hope you enjoyed. Yeah.